Okay, so a while ago I tested this UGREEN charger and it is excellent, super powerful, really fast, but it also never really gets hot. And part of that is to do with the NEXODE technology, which is using gallium nitride and according to AI allows more efficient and compact charging. Now this is a 500 watt USB-C charger and it also has a USB-A port on it as well. It is so heavy, according to my scales. Yeah, 2.2 kilograms. So let's have a look inside. So it comes with a very heavy duty kettle lead. And as you can see on the front here, 240 watts is the maximum speed that it can charge. I don't think I've got anything that charges anything like that speed. And these are all 100 watt. So 4 times 100 watt. And then a USB-A socket as well. Just a big 500 watt written on the side. The kettle connection. Nothing here. And then some really nice chunky feet on it, which is good because it's such a solid piece of kit. Now it doesn't come with any USB-C cables, but luckily I already have this 240 watt one that Orico sent me a while ago. And I've never had anything that goes above about 40 watts. But before I start plugging things in, let's have a look at their website for all the specs. And something that's just struck me is that there's no vents on this at all. So this gallium nitride is going to be very efficient at keeping cool. If you think of a 500 watt PC power supply, it's got a big fan and heatsink and stuff like that in there. This is going to be a silent cooler. So if you are charging lots of devices in an area that you don't want noise, or you're powering a computer and monitors and various things with USB-C, it's not going to make any noise, which is great. And I was looking for some pictures of gallium nitride to see what it looks like, and I came across this site which is basically talking about the benefits of gallium nitride. It's growing in importance because of its ability to offer significantly improved performance across a wide range of applications while reducing the energy and the physical space needed to deliver that performance when compared with conventional silicon technologies. This image pops up a few times when you do a search for it, but it seems to be used in all sorts of things. So we can see cars, which very important to keep as cool as possible, and they use incredibly high amounts of power. But yeah, really interesting. So back to the specs. So power delivery 3.1 spec, 240 watt, mind-blowing 500 watt output, so 6 devices maximum, 5 laptops. Tip over protection, automatic power reduction. You'd certainly know if you knocked it over. It would make quite a noise if that slammed down on the desk. So MacBook Pro goes up to 140 watts. USB-C and USB-A. There it is, powering up laptops. I'll be plugging all sorts of things into it to give it a try. I need to make some more space on my desk for it because this will be very useful for me testing different products. So you can see how good it is in this sort of scenario, so where everybody's got their computers and it just means it's a lot neater. Yeah, gaming computers would make use of this power. Sleek minimalist design. So 11 level power protection, over voltage, over power, soft start, anti-interference, over temperature, over current, fire resistant enclosure, lightning protection, short circuit protection, electrostatic and anti-surge. So you can see why it would be compatible for the future. 240 watts is going to be good for a long time. So 20 watts from the USB-A. Oh, and here's all the configurations. So with 2 ports, we can have 240 watts and one at 100 watts from any of those 100 watt ports. And then we go to the 3-port output, so 240 plus 100 plus 100. And then 4-port output, 240, 100, 100, and then 60 watts. So it's just managing it to say under 500. So 5-port output, 240 watts, and then 4 at 60, or you can manage it a little bit different. It seems to take precedent to the top one, and then the next one down in that order. Yeah, because in this scenario where it's got 240, they've left one out of here. The next available one gives 100, and then we've got 60, 60, and 20. And there's the 6-port output. I mean, 60 watts is faster than my MacBook. Well, it's double the power of my MacBook charger anyway. So that's so impressive. And various different specs in here and supported protocols. PD 3.1, PD 3.0, PD 2, QC3, QC2. Right, let's plug some things into it. So I plugged in this Minis Forum Mini PC. So this is USB-C going into this. I'm not using the power supply that came supplied with it. It comes with a a barrel jack. It's also powering, I've got a USB A to C powering this monitor as well. And as you can see, all that is working. But then I thought, there's no lights on this, and there's no real way of knowing how many watts it's using. Unlike the UGREEN power bank that I've got, which tells me exactly how many watts each device is using. So if I plug my iPad into the power bank, I can see that it's using 21 watts at the moment. It was saying 30 watts initially. I'm going to use my smart plug, so I'm going to shut this down, plug in the smart plug. So the smart plug is going to go into this, so it will show me how many watts this is using. So currently at 22 watts. Let's launch a game, because that's bound to make a bit of a difference. Does it go higher if I jump in the car? Okay, that's taken us up to 31 watts. That's a start. Let's plug some more things in. This USB-C cable has a display on it. It can tell me how much power it's using. I'm going to plug it into my MacBook, which is only a 2020 M1 MacBook Air, so it doesn't take loads of power. So 29, 34 watts, 39, oh quite a bit, 43 watts. That's good. So we're up to 79 watts already. Need to plug in the big one, the Snapdragon laptop. And I need to widen my camera. I don't know how high this goes, but that's a 240 watt cable. So let's plug that into the top one, the one that it can give most power to. And what have we gone up to? So I saw the blue light come on. So only 77 watts. MacBook's charging at 40. 119 watts. There we go, now we're talking. Now this has got a cracked display which you can't see from here, but the display doesn't work. So what I have to do is use a USB-C monitor like the WiMAXit. Use my fingerprint to log in. So that's working on touchscreen. So what we're at now, 138 watts. Plug another monitor into this. I need to plug it into this really. So let's plug it into the front of this Minis 4M PC, because this doesn't have a battery in it, so it will pass power onto the WiMAXit display. So that lights up. Plug HDMI into the laptop. That's picked up dual displays on here, so I've got two displays running here, and that's being powered from that mini PC. And I've still got a USB-A and two USB-C. So into the USB-A I'm going to plug in a phone. So this is a Honor View 20, 77%, so that shows that it's charging. And a Raspberry Pi 5. Let's take power from here and into the Pi. I just need power for that monitor now. And I'm hoping the Pi will supply enough power to it. It doesn't, so I need to take the USB power from somewhere else. So what I'm going to have to do is take the power from this mini PC, which will still be taking the load from the UGREEN. So USB-C to A from the little Minis 4M PC. The Pi has a limitation about how much USB output it can supply. Okay, so that's come on. All of that's working. So we're currently at 154 watts, and I've still got a USB-C socket. I would imagine my iPad is probably one of the only things that can charge at quite a quick speed. Not sure what this USB-C cable can deliver, but let's plug it in and we'll see. I'll leave this screen on. Okay, so that's every socket taken up. Currently using 169 watts at the moment. So this is charging 59% and it's using 39 watts, or it said 39 just now and then it dropped to 33. My Raspberry Pi is plugged into here, so that's powering that. The monitor is being powered by the mini PC, which is also powering this monitor as well, so that it's not coming from the laptop. And that monitor is plugged into the laptop. This monitor is coming from the mini PC as well. So that's doing quite a lot of work. There's all sorts of things plugged into that. There's all of the sockets are taken up, providing power, and the game is still running. So it certainly does enough for me. So I really would need some sort of gaming laptop or top-end MacBook Pro to kind of max it out. Or I could introduce, I've got more mini PCs that are powered by USB-C. So the bigger the processor, the bigger the draw is going to be on that. So under all that pressure, this is silent and I can't detect any temperature from it at all really. It just feels like room temperature. So if I touch that and yeah, the surface, it just feels pretty much the same temperature. It doesn't feel warm at all. But yeah, super impressive. It's going to be really useful for me. I'm definitely going to use this on my desk and it will show up in loads of videos in the future. Okay, so I hope all this helps. Thanks very much for watching. Please like and subscribe.